Welcome back. In the second lesson in this section, we will make a centralized controller. That means one controller that controls whole of this operation. To do that, let's close this, maximize this so that you can see a lot more information. Also remove the watch and clear the solution. It's optional if you want to keep your soft runtime running, but in my case, since it's going to be a while before we deploy this and run again, I'm going to close it. Okay, let's minimize that, and under basic you will see that there is a folder called model and all the model related function blocks are here. So obviously we are going to go create a new folder for control. Now this hierarchy and this kind of design decisions is left to you. I personally like to have 2 different folders, or maybe 3, depends on the use case. In my case, I'm going to have all the blocks related to the model in the model subfolder and all the blocks related to control in the control subfolder. And here we're going to add a new item. Let's call it central control. Okay, because it's a centralized control. And the main goal here would be that you take your app and you take this away and replace this with a controller of your own. Okay. Now, how does the interface should look like? Whatever are the inputs here becomes the output of the controller, and whatever the outputs are here becomes the input of the controller. So we have 3 inputs here and 6 outputs. So it will be the other way around for the central controller. So let's go ahead and do that. For the input was, we don't need QI, so we will instead use lift retracted, and then the other version of that, lift extended of type bool. Then we have pusher retracted. I just want to confirm the order. It's just easier if you meant in the same order. So let's go back here and see, okay, retracted, extended, then arrived and lifted. So let's do that. Pusher extended of type bool. Then we had luggage arrived, and then we have luggage lifted. Okay. Now you can see that it's not associated with any events, so let's get associate them with all the events. Because you have a single event to process, we will do that. And similarly, we will have control actuations, which will say extend lift to extend the lift. Then we will have retract lift, and then we will have extend pusher. Similarly, associations, let's go ahead and do that. Okay. Okay. That's the interface is done. Now we need to do the ECC. All right. How do we do this? Let's do a plan, right? We don't need this, so let's get rid of that. We will always start with initialize. We probably won't come back to the start state because it's going to be some kind of cycle. So when you initialize, you never know what the physical status of the system is. So in the initialize, what you want to do is make the system go to its default position. That is, the lift should be retracted, the pusher should be retracted, and that's what we're going to do in initialization. So let's go to algorithm, go to init, and say that what did we have? We had extend pusher. We need to make sure that this is false. Okay, just to make sure that it's in retracted position. So make it false so that it starts retracting, even if it's not. Because it's a single acting cylinder, it should be safer, but it's just easier that we design our control in such a way that we make sure that initialization means it should go to the default position. Extend pusher should be false. I have to go back to interface and check what I called it. Extend lift. So extend lift should be false. However, retract lift should be true. Okay. So that you're saying that, okay, let's see if, depending on whatever the situation is, let's try to retract it. Now, that's well and good. Now, once it is initialized, you will go to a new state. Let's call it initial because it's going to be the initial state. And after initialization, you will come to initial state. When do you come to initial state? Now, when you get request from the plant that it has done what it has supposed to do, and I need to go back to the interface and see my sensors. Maybe I do remember. Let's see, what did I call them? Extend? No, it was the other way around. So pusher is retracted. So we asked the pusher to be retracted. So we want to check if the pusher is now retracted. And we also made, remember, that retract lift or lift retract. We asked the lift to get retracted. So we want to check if the lift is retracted. Okay. I hope this is clear. You're waiting for the request event, and also you're going to check that the pusher is in retracted position and the lift is in retracted position. So once this condition is satisfied, you go to initial state. That means everything is good. And of course, remember, we need to turn the lift retract to false because it is set to true. So we do that in an algorithm called initial. Let's add an algorithm called initial. And there is an option to, it says go to editor. So since we are adding that, we'll say after adding this algorithm, go to editor because we need to put something in that algorithm. And also we want to associate it with the current action on which we clicked. So that's good. So when we do that, it will go here and retract lift, we're going to make it false because once we are in this state, we know that we don't need to retract anymore. And go back to ECC and you will see that that was automatically populated. That's one of the features of NxtStudio. So you don't have to go to algorithms, right click, add algorithm, go to ECC, add action, and all that. Okay, let's continue. Before we continue from this initial position, let's add all the possible states. Okay, what would be the next state? Next state is that the baggage will arrive and you want to lift the luggage. So let's call that state as lift luggage. Okay, what would be the next state? You ask the lift to be lifted and it will get lifted. Once it gets lifted, you will want to push the luggage, right? Once you push the luggage, you would want to get your both the mechatronic systems back to its place. So let's have a state saying luggage was pushed, so that you can set respective actuations to false and true in this state. And after this, you will go back to initial state. Okay, so let's do some actions and algorithms. Add action and click on this and say new algorithm. We will it's called lift luggage, so let's keep it short and call it lift luggage. What happens in lift luggage? Your extend lift becomes true, right? Extend lift will become true. Okay, sounds good. And that is populated. Every time you make any changes to the sensor values, make sure you emit CNF event. When do you come to the lift luggage state? You will come here when you get a request event and luggage arrived, right? We saw the sensor from the environment that whenever luggage comes and it's ready to be lifted, luggage arrived sensor is true. So whenever you get a request and luggage arrived is true, we want to lift the luggage. That's what we're doing. We are going to lift the luggage by extending the lift. And in the push luggage, what we're going to do is push the luggage. Now here we need to do two things. One is extend pusher will be true. And remember, we made extend lift to be true. If we are in this state, that means that the lift is completely extended. So we will unset it. Okay. Let's go back to ECC. Remember to emit CNF. And when do you arrive here? You arrive here when you get request and your lift is extended. Okay. You can also check if luggage is lifted as well. Okay. So it's a double check just to make sure that while lifting the luggage did not fall off, for example. In that case, the luggage will not be lifted and you don't need to push it. Okay. So that's another condition. We will not get into details about other conditions. So we will assume that this will be always the good case. No luggage will fall off. So we don't want to handle such scenarios. Okay. Ideally, what you will have to do is add a new state, handle the other condition of this that might happen. And then if that's the case, you just go back and raise an alarm or an event saying that, hey, I was trying to lift the luggage, but it looks like it fell off or somebody removed it or something like that. Okay. Luggage is pushed. How do we know luggage is pushed? We know that when we get the request event and pusher is extended. Okay, once the pusher is extended, we know that luggage is pushed. What should be done when the luggage is pushed? We will call it luggage pushed. If you have noticed, I am following a particular naming convention here so that it's easier to associate. And I'm trying to just use a shorter version of the state name for the algorithms. Okay. What did we do in the last action? We made extend pusher to true because now extension is done. We're going to set it to false. And we are also going to ask the lift to go down. So retract lift will be set to true. Okay. And that is done. Go back to ECC. After this, what we do is initial position, if you remember in the initial algorithm, we are already doing retract left equals to false, which we had set to true here. Okay, so when do you go to initial state? When you get request and pusher is retracted and lift is retracted. Okay. Let's save that, build to see there are no errors. Okay. Sounds very good and looks very good. Looks like I still have some watches, so it's showing me some errors about some watches that I added when I was doing the last lesson. Seems to have not cleared well. That's okay. It will get cleared when we next time deploy it. Okay, so that was the central control. That's the ECC. That's the end of this lesson. In the next lesson, we will instantiate this control, make the connection, and test it. Okay, see you in the next lesson.